Hello everyone, I am Darshan A, Assistant Professor of Mathematics. In the previous sessions, we learned about limit of a function, what is left hand limit and what is right hand limit, when does limit exist and when does limit does not exist. In this session, we are going to solve some examples. Let's get in. Consider the first example. If f of x equal to 3x minus 2 when x less than 1, f of x equal to 4x square minus 3x when x greater than 1, find limit of f of x as x tends to 1 if it exists. First, let us find out the left hand limit. LHL is equal to limit of f of x as x tends to 1 minus. 1 minus represents we are approaching 1 through the values less than 1. The values less than 1 will be of the form, this is 1. For h positive, the values less than 1 will be of the form 1 minus h. So I substitute x equal to 1 minus h and let h tends to 0. This will be equal to limit of f of 1 minus h as h tends to 0. Now, by the definition of f of x, if x is less than 1, f of x equal to 3x minus 2. Here 1 minus h is less than 1, therefore f of 1 minus h is equal to 3 into 1 minus h minus 2. Now, simplifying this, I get limit of h tends to 0, 3 minus 3h minus 2. As h tends to 0, I get 3 minus 0 minus 2, which is equal to 1. This is the left hand limit. Now to find out the right hand limit, I consider RHL is equal to limit of f of x as x tends to 1 plus. 1 plus represents we are approaching 1 through the values greater than 1. Any value greater than 1 will be of the form 1 plus h, where h is a positive real number. So I substitute x equal to 1 plus h and let h tends to 0. This will be equal to limit of f of 1 plus h as h tends to 0. Now if you observe here, f of x is defined as 4x square minus 3x whenever x is greater than 1. 1 plus h is greater than 1, therefore I use this definition. This will be limit of 4 into 1 plus h whole square minus 3 into 1 plus h as h tends to 0. Now let us expand this and substitute h equal to 0. Limit of h tends to 0, 4 into 1 plus h square plus 2h minus 3 minus 3h. Again simplifying this, I get limit of h tends to 0, 4 plus 4h square plus 8h minus 3 minus 3h. Now if I substitute h equal to 0, this term will be 0, this term will be 0 and this term will be 0. So I remain with 4 minus 3, which is equal to 1. We have LHL equal to 1 and RHL equal to 1. Since LHL equal to RHL, limit exists at x equal to 1. Limit exists at x equal to 1, and we can write limit of f of x as x tends to 1 is equal to the common value of LHL and RHL, which is 1. Now consider the next example. If f of x equal to x minus 2 whenever x less than 0, x square minus 1 when x is greater than 0, Find limit of f of x as x tends to 0 if it exists. First we need to find out the left hand limit LHL, which is equal to limit of f of x as x tends to 0 minus. We are approaching 0. From the values less than 0, I have to substitute x equal to 0 minus h. Put x equal to 0 minus h and let h tends to 0. By the definition of f of x, for the values less than 0, f of x is x minus 2. So f of 0 minus h is 0 minus h minus 2. As h tends to 0, I get minus 2. Now to find out RHL, which is limit of f of x as x tends to 0 plus, I have to approach 0 from the values greater than 0. The values greater than 0 are of the form 0 plus h. So I substitute x equal to 0 plus h and let h tends to 0. Limit of f of 0 plus h as h tends to 0. By the definition of f of x, for the values greater than 0, the function f of x is defined as x square minus 1. So this is equal to limit of 0 plus h whole square minus 1, which is same as h square minus 1. Now if I apply the limit as h tends to 0, I get 0 minus 1, which is minus 1. Here the LHL at 0 is minus 2, RHL is minus 1. Since LHL is not equal to RHL, the limit of f of x as x tends to 0 does not exist. Now let us consider the next example. Evaluate limit of x by mod x as x tends to 0 if it exists. Before solving this example, first we need to know what is modulus of x. Modulus of x is a real valued function defined by x if x is greater than or equal to 0 and minus x if x is less than 0. The graph looks like this. This is 0. Okay. So first let me take this function as f of x. F of x equal to x by mod x. Now let us find out LHL and RHL. LHL is equal to limit of f of x as x tends to 0 minus. I substitute x equal to 0 minus h and let h tends to 0. Limit of f of 0 minus h as h tends to 0. And this is equal to, since f of x is x by mod x, this is minus h by mod of minus h as h tends to 0. Now by the definition of mod x, if it is positive, it is equal to x. If it is non-negative, it is equal to x. If it is negative, it is equal to minus x. Here minus h is a negative number since h is positive. So this will be equal to minus of minus h. This is equal to limit of minus h by minus of minus h as h tends to 0. Minus into minus plus, h gets cancelled. I get here minus 1. As limit of minus 1 as h tends to 0 is equal to minus 1. Now let us consider RHL, which is equal to limit of f of x as x tends to 0 plus. Put x equal to 0 plus h and let h tends to 0, where h is a small positive real number. Take limit of f of 0 plus h as h tends to 0. By the definition of f of x, this is equal to h by mod h as h tends to 0. Since h is positive, by the definition of mod x, it should be equal to h. This is equal to limit of h by h as h tends to 0. H gets cancelled, so I get 1. the limit of 1 as h tends to 0 is equal to 1. Here I have LHL equal to minus 1, RHL is 1. LHL is not equal to RHL. Since LHL is not equal to RHL, the limit does not exist. Limit of x by mod x does not exist. Consider one more example. If f of x equal to 3 minus x square if x is less than minus 2 and 11 minus x square if x is greater than minus 2, find limit of f of x as x tends to minus 2 if it exists. As I explained earlier, you can find out the left hand limit and right hand limit. If they are equal, limit exists, otherwise limit does not exist. In this case, I get LHL equal to minus 1, RHL equal to 7. They are not equal, therefore limit does not exist at x equal to minus 2. But how to visualize this graphically? In general, you can find out the limit theoretically using left hand limit and right hand limit. Now I am going to tell you how to visualize this graphically. In our syllabus we have Maxima in practicals. You can download the Android version of Maxima by Play Store. Just define this function and plot this function in this interval, in an interval which contains minus 2. To define this function, I define f of x colon equal if x is less than minus 2, then 3 minus x square, else 11 minus x square. Now let us plot this function in an interval which contains minus 2. Plot 2D f of x comma, I consider the range of x as minus 4 comma 0. The range of y is not mandatory. You just type this in this app. You get the graph of this function like this. Clearly by the graph, the left hand limit approaching minus 2 from the left hand side, it is approaching minus 1. Approaching minus 2 from the right hand side, it is approaching 7. As they are not equal, limit does not exist. Similarly, you can plot every other graph and you can visualize the limit geometrically.